In the vast and seemingly endless expanse of our universe, a groundbreaking revelation emerges from the shadows. After painstaking years of research, combing through cosmic mysteries and astronomical data, the scientific community stands on the precipice of an awe-inspiring discovery: the first ever recorded white hole. Why should this revelation send chills down your spine? Why are the experts whispering excitedly in their observatories? And what, dear listener, does it all mean for you? Dive with us into this cosmic enigma and let us unravel the universe's latest secret. Most have heard tales of the dreaded black holes, cosmic monsters hiding in the far reaches of our universe, ever hungry and ever consumptive. They are voids that devour everything, from the smallest particle to the largest star. Yet, in a world of balance and opposites, the universe holds a counterpart to the black hole, the elusive, just as mysterious white hole. Understanding the black hole is our key to unraveling the mystery of its luminous twin. One might envision a black hole as a cosmic beast of various sizes, each type bearing its own tale of terror and intrigue. Primordial black holes. These enigmatic entities, believed to have been formed just moments after the universe came into being with the Big Bang, are minute, no larger than a single atom. Yet they harbor the mass equivalent to an entire mountain. Their size belies their power, making them the universe's master of disguise. Stellar black holes, a paradox of cosmic proportions. Though their mass can outsize our sun by up to 20 times, their physical size is deceptively compact. Picture this: a massive entity with the might to exert a gravitational force unparalleled, confined within a mere 10-mile radius. The Milky Way, our cosmic home, is believed to host dozens of these dark marvels. Supermassive black holes. These are the titans among titans. Holding a mass greater than millions of suns combined, they command the core of every massive galaxy. The heart of our Milky Way, for instance, is presided over by the formidable Sagittarius A, an entity of staggering size, boasting a mass equivalent to 4 million suns. Yet its enormity could be contained within a sphere roughly the size of our own sun. But what births these enigmatic entities? Primordial black holes are believed to be remnants from the universe's nascent moments, relics from a time of chaos and creation. Stellar black holes are birthed from cosmic pyres as massive stars implode, unleashing a supernova's fury and casting starry remnants into the great beyond. And the colossal supermassive black holes. Their origins intertwine with the galaxies they reside in, growing in tandem, their sizes reflecting the very galaxies they anchor. These cosmic behemoths, however, remain elusive, their true form hidden from our gaze. Their gravity is so profound that even light, the fastest entity known to us, cannot break free from its shackles. Yet, scientists, with their indomitable spirit, have found ways to study these entities. By observing stars and gases reacting under a mysterious gravitational influence, experts can infer the presence of a black hole. This gravitational dance between a star and a black hole, under the right conditions, births an accretion disk, a swirling vortex of gas. As this gas is drawn inexorably into the black hole's maw, it emits powerful X-ray light, a beacon signaling the presence of these enigmatic entities. But if this is the narrative of the black hole, what tales does its radiant twin, the white hole, hold? As we delve further into this mystery, hold on to your seats. The journey is just beginning. NASA's state-of-the-art telescopes, the vigilant eyes in the skies, measure this brilliant X-ray light. Harnessing this information, astronomers embark on a journey deep into the essence of black holes, decoding their enigmatic behaviors and idiosyncrasies. And as you sit on the edge of your seat, you might be pondering, could our very sun, the fiery orb that graces our skies, ever transform into one of these devouring voids? Though it might be an unsettling thought, breathe a sigh of relief. Our sun lacks the critical mass required to metamorphose into a black hole. However, this does not grant it eternal life. Fast forward billions of years, and a breathtaking celestial transformation awaits. Our sun will swell into a majestic red giant, outshining its former self. As it exhausts its nuclear fuel, it will release its outer layers in a final radiant display, birthing a planetary nebula, a glowing ring of ethereal beauty. Eventually, all that remains will be a fading ember, a white dwarf star, a quiet testament to the sun's luminous legacy. Yet, such cosmic events lie so far ahead. It's but a fleeting thought in the vast tapestry of time. But, dear listener, here's where our tale takes a dramatic twist. Enter the white hole, the antithesis of its shadowy counterpart. Imagine, if you will, a black hole, but rewound in time. If the black hole is a cosmic whirlpool, devouring everything in its vicinity, the white hole is the fountain from which matter and light erupt. This curious region in space-time propels everything outwards, forbidding even the mere entry of light. Its radiant power mirrors the all-consuming darkness of a black hole. Any vessel, no matter its resilience, daring to approach would find itself obliterated by the overwhelming barrage of gamma rays. Even if, hypothetically, a ship could withstand this energy onslaught, the space-time around the white hole evolves in such a manner that entry would demand more energy than the entirety of our universe can offer. This enigmatic concept of white holes emerged from an academic dalliance with the mathematical models of black holes. Flashback to 1905. The brilliant Albert Einstein unearthed a profound truth. Observers, when accelerating, perceive time differently, a phenomenon that does not translate to those moving at a constant speed or remain stationary. This epiphany, coupled with the invariant nature of light speed, paved the way for his monumental theory of general relativity. Here, Einstein unveiled that objects with mass didn't just exhibit gravity as a mere force, but distorted the very fabric of time and space. Following Einstein's groundbreaking insights, Carl Schwarzschild meticulously dissected these field equations, leading him to an equation depicting mass within a void, an area devoid of any matter. This gave birth to the Schwarzschild metric, a mathematical masterpiece too intricate to delve into here, but in essence, it provided a representation of a black hole. In Schwarzschild's conception, this black hole was a timeless entity, an eternal void that never altered in size or charge. Now, to visualize the implications, at the event horizon, all events seem to stretch into an infinite future. To an observer, they appear to be suspended, never fully materializing. The Schwarzschild metric illustrated that, within this enigmatic black hole, the very notions of space and time interchange, with the black hole's core representing an inexorable future rather than a tangible location. Turning back the clock on such an eternal entity, we arrive at the concept of the white hole. However, the existence of white holes remains a topic of contention among the scientific community. While they align with the laws of general relativity and showcase mathematical elegance, their tangible manifestation in our universe remains a subject of debate. Many dismiss white holes as impossible possibilities, entities that, while they cannot be wholly refuted, are yet to grace our telescope's lenses. The recent groundbreaking discovery of a white hole has only served to ignite these debates, challenging our understanding of the cosmos. For centuries, the foundational laws of physics have served as guiding lights, helping us navigate the often mysterious terrain of our universe. Yet the perplexing phenomenon of white holes threatens to upend our understanding, clashing directly with the revered second law of thermodynamics. This cardinal law dictates that entropy, the degree of randomness or chaos in a system, must either remain unchanged or escalate. Let's pause for a moment and delve deeper into this enigma called entropy. At its essence, entropy is the measure of potential states a system can occupy. Imagine, for a moment, a majestic house systematically reduced to a pile of rubble. This destruction epitomizes an augmentation in entropy. Why? Because the resulting rubble can be reconfigured into an array of different constructs, from rudimentary sheds to elaborate bookshelves. Whereas the house represents a single, ordered state, the rubble represents myriad possibilities, signaling an elevated entropy. However, in the cosmic tapestry, there can be fleeting, localized dips in entropy, provided they're offset by an overall upswing in entropy elsewhere. This delicate balance ensures that the universe's cumulative entropy adheres to the second law. Enter the black hole, a veritable master of entropy manipulation. These enigmatic voids absorb structures replete with order, like our very planets, and, over vast epochs, redistribute their components across the vast expanses of space. This act contributes to the sprawling chaos of the cosmos, ensuring entropy's dominance. In stark contrast, white holes challenge this balance. Their very essence, expelling matter back into the universe, seemingly defies this established law, appearing to reverse the flow of entropy. It's akin to watching the aforementioned house magically reconstruct itself from the rubble, a spectacle that, according to our current understanding, borders on the fantastical. This perceived violation also underpins arguments against time reversibility. If time could flow backward, entropy would naturally decrease, contravening our thermodynamic principles. But as with all things cosmic, the debate is far from settled. Theoretical physicist Carlo Rovelli presented a radical idea that catapults this discourse into exciting realms. Rovelli proposes that when black holes reach a point where they can't evaporate or contract further, due to the intricacies of spacetime, they might undergo a quantum leap of sorts. This transformation, described as a quantum bounce, could convert the inward consuming black hole into an expelling white hole. If Rovelli's hypothesis holds water, it insinuates that the moment of a black hole's birth could simultaneously mark the inception of a white hole. The mind-bending element. This metamorphosis transpires almost instantaneously. But to us, ensnared in the web of space and time, this instantaneous transformation appears extended over billions of years, thanks to the intricate dance of gravity and time dilation. Thus, the universe we observe might be masking secrets and transformations beyond our wildest imaginations, constantly challenging our understanding and beckoning us to seek deeper truths. In the grand tapestry of the universe, few phenomena evoke the same sense of wonder and unease as the mysterious black holes. But what if the end of a black hole's life cycle was just as intriguing, if not more? What if, upon their death, they unleashed a spectacle that could reshape our understanding of the cosmos? Rovelli's theory, audacious in its claims, suggests that ancient black holes could be on the cusp of a grand finale, nearing their death throes, and poised to erupt into a radiant display of cosmic rays or other forms of radiation. And perhaps, just perhaps, we've already been privy to such a spectacle. Flashback to 2006. The night sky, ordinarily a tranquil expanse, was disrupted by a dazzling display. NASA's Swift satellite captured a gamma-ray burst of unparalleled intensity, codenamed GRB 060,614. This burst emanated from an enigmatic sector of the cosmos. Gamma-ray bursts, as celestial phenomena, are typically pigeonholed into two categories: short bursts and long bursts. These illuminations are often the death cries of stars, culminating in supernova. Yet, GRB 060,614 defied this understanding. Not only did it illuminate the sky for an astounding 102 seconds, far surpassing the average 2 to 30 seconds most gamma-ray bursts endure, but it also wasn't tied to any known star explosion. Its origin: a galaxy notably bereft of stars capable of such theatrics. The phenomenon was akin to a brilliant firework igniting from thin air and then, as if overwhelmed by its own splendor, folding back into the abyss, leaving only questions in its wake. It wasn't until years later that a potential answer emerged, connecting GRB 060,614 to our discussion on white holes. Scientists postulated that this uncharacteristic gamma-ray burst might have been the handiwork of a white hole. And why did they gravitate towards this audacious conclusion? Because the characteristics of GRB 060,614 mirrored the theoretical behavior of a white hole. Imagine a gargantuan volatile geyser of matter and energy, surging forth with unparalleled vigor, only to retreat and vanish, all emanating from a point in space so minuscule it defies detection. This hypothesis' credibility is bolstered by the sheer absence of alternative explanations within our current scientific framework. GRB 060,614, in its fleeting magnificence, challenged existing paradigms, urging the scientific community to think beyond the known. Its legacy, whether the dying gasp of a black hole's transformation or an entirely new celestial riddle, continues to captivate and beckon us to explore the enigmatic expanse of the cosmos. In the infinite cosmos that stretches beyond our imaginations, every discovery, every hint of the unknown, pulls us closer to understanding the universe's intricate dance. As we stand at the precipice of what might be one of the most significant cosmic revelations, your involvement becomes crucial. By liking, you push forth the essence of such incredible stories, ensuring they reach the curious eyes and ears of many. Your comments become the heartbeat of a global conversation, pushing the boundaries of what we know and propelling us to ask deeper, more challenging questions. And by subscribing, you not only embark on this cosmic journey with us, but also empower and inspire its continuation. Together, let's unravel the universe's enigmas and stand witness to the wonders it holds.